I'm going to try something a little bit new today, and we'll see if this works. So I'm just walk through the review guide for you, and then tomorrow we will answer questions that you may have. We talked about these problems uh, today, but let's go ahead and step through them in not more detail, but maybe a little bit slower for some. But you want to make sure you come with questions when we meet. It's not just a case of getting the assignment done. It's a case of understanding. So what we talked about is that if we can use this f of x equals x squared as our parent function, which is the basic quadratic equation, then we can actually determine what's going to happen to another quadratic equation just based upon its form. And the form we're using is y equals a times x minus h squared plus k. This is called vertex form. The vertex is located at h and k. The h tells you the horizontal translation, the shift, left or right. The k tells you the vertical translation, up and down. The a value, so I'm just highlighting each of these. So there's the h, this is the k, and then lastly the a value. And the a value tells you two things. It tells you, does it open up like this or down like this? And it tells you if it's going to be stretched vertically or, sorry about that, or whether it'll be compressed vertically but just non-stretched. It'll actually be a horizontal stretch at that point. They call it, I believe, a shrink, or whether it will be shrunk vertically. Okay, so let's look at how we apply that to g of x here. All right, so I'm just going to write down that vertex form right below it. I'm going to compare parts. I'm going to say, all right, what is in front of the parentheses? That's the a value. In this case, they don't show anything. Well, that's an implied 1 there. It's got to be a 1. If it's a 0, the whole thing disappears. So we can tell a is 1. We have to be a little careful inside here to figure out what h is. If h was 4, it would read x minus 4, but it doesn't. It reads x plus 4. Therefore, h must be a negative 4, giving us x minus negative 4, which is a plus 4. So our h in this case is going to be a negative 4. And finally, our k value. The k value is what's hanging on out here. You can see there's nothing there, so k is 0. That right away tells us what the vertex is. Our vertex, remember, is at hk. And so vertex for this is at negative 4, 0. And the parent function, and let me show you this graphically very quickly. You don't have to graph this to solve it, but you have to be able to graph it, or at least pick out the correct graph. So let me show you what's going on here. I'm going to graph the parent function real quick, the y equals x squared. The f of x equals x squared. They mean the same thing. There's our x, there's our y. Here's y equals x squared. You can just generate some points really quickly. 0, square, you get 0. Plug a 1 in for x, you square it, you get 1. Plug a 2 in for x, you square it, you get 4. 0, 0, 1, 1, and 2, 4. Now if you recall, if you don't, you should now, the axis of symmetry goes right through the vertex, and so by virtue of that axis of symmetry, we have matching points. So there's what our parent function f of x equals x squared or y equals x squared looks like. This new function, g of x, it has a vertex of -4 in the x, so I'm going to add a few tick marks, and 0 in the y. Its a value is exactly the same as the parent function. Remember, there's a 1 in front of that x squared. So this parabola does exactly the same thing. I know his vertex, therefore I know his axis is symmetry. I also know to have the same shape, he has to go over 1, up 1, over 2, up 4. And symmetry tells me this point, and tells me, let's go over one more, that point. So there is the graph of g of x. Same thing as the purple function, the parent function, just shifted or translated left by 2 units. So, describe the transformation, we would simply write f of x is translated, or g of x is a translation, but it is a translation left. By how much? Well, it looks like 1, 2, 3, 4, exactly what our h value was, 4 units. So that's all we're trying to do. How is it translated, and how can we graph it if we know that translation? I'm going to clean up a little bit of this so we can attack the next problem. All right, the next problem. So think of this as just like a blank slate, and you are presented with problem number 2 here. We'd say, okay, we got to tell you how it's transformed. Fine, no big deal. Ax minus h squared plus k. We read a is 1, the number in front of the parentheses. H is the 7, because the x's match up, the minuses match up, therefore h has to be 7, and the k is 2. And so the vertex for this is at 7, 2. And so we say translated right by 7 units. Translated up by 2 units. If we want to pick out the graph for this thing, we should be able to make a sketch of it pretty quick. Vertex 1, 2, 3, 4, 5, 6, 7, up to. There's my vertex. The a value is 1, which means it looks just like the parent function. Remember that parent function has these points, 0, 0, 1, 1, 2, 4. And so we just count those from this vertex. 1, 1 is going to give it the exact same shape, and then over 2 and up 4. So we just plot those points, over 1, up 1, and then over 2, up 4. And then our matching points, because of symmetry. We knew where it was going to start, and we knew its shape because the a value was 1. Let's clear all this. See, I should have a clear. Yeah, maybe not. Let's just go ahead and erase it all. Let's look at problem 3. Now 3 presents something a little bit different just because the a value has changed. So let's take a look at 3. There we go. In this case, a times x minus h squared plus k. You can see a is -3 in this case. That has some repercussions. X, just like we can't say it was, I forget what number it was in problem number 1, but h is not 2 here because of this plus sign. You got to think of it as a minus 2. So the negative matches the negative, forcing h to be a -2. So I have an x there. except h does tell me the x value of the vertex, but h is -2, and k in this case is -1. So we can see it shifted left by 2, it shifted down by 1. But let's talk about this a value. A affects two things. If a is less than 0, that means negative. Then it's going to be sad. That means the parabola will open upside down. If a is bigger than 0, that means positive. A is happy. It'll make a smiley face. It'll open upward. Okay, this is called a reflection about the x-axis. In other words, it flips it over the x-axis and makes it go upside down. Otherwise, it isn't a reflection, and it says a is greater than 0. So clearly in this problem, because a is negative, this parabola is going to open upside down. So think about that for a second. Let's go ahead and start that graph. You'll see how simple this is. I already know my h and k. Remember, that's my vertex, -2, -1. So as I start to graph this, I know it starts at -2, -1. I know it's a shift or a translation left by 2 and a translation down, a vertical translation down by 1. So my parabola starts there, and I already know since a is -3, it's going to open downward. Now the second part that a tells us, besides the fact that it's opening downward, is it tells us the shape. When a was 1, it looked just like y equals x squared. But now a is 3, so it looks like y equals 3x squared. Now we could generate points for this, but we don't have to because we just need to get an approximate graph. If we want to graph it perfectly, we'd use software for it. And here's the deal. Forget about the negative sign. If the absolute value of a is greater than 1, so it could be 1.1, 1.2, 2, 3, 4, 5, 6, any number bigger than 1. The absolute value just means take away that negative. If it's greater than 1, it's going to be narrow. It will be stretched. We're writing too small. Let's call it a vertical stretch to be appropriate. If the absolute value of a is less than 1, so this is a fraction. Think of it like half, 1/3, 2/3. Then it's going to be stretched horizontally. It'll be wider, or it'll be compressed vertically. In this case, the absolute value of -3 is just a +3. 3 is much bigger than 1, and therefore it's going to be a skinny parabola, like so. The only way you get yourself a wide parabola, one that is compressed in the y direction, making it flatter, would be something like this, 1/2 x plus 2 squared minus 1. This 1/2 now, if I was graphing that, it'd have the same vertex, -2, -1, but it would be a wider parabola. Again, we don't have to be perfect here. We just have to be able to kind of have a sense of, is this parabola going to be like the normal one, a is 1? Is it going to be stretched vertically, skinny, because the a value, absolute value of a is bigger than 1? Or is it going to be compressed or stretched in the x direction because that a value is a fraction when you take its absolute value? And that is it. So if we were answering this question to be make sure we understand how to answer it, we'd say translated left by 2, translated down by 1, and vertical stretch by a factor of 3, and reflected, remember that's what the negative sign does, over the x-axis. Turned it upside down. So there's a lot going on with that equation, a lot packed in. Let's look at problem number 4. And 4 plays off of number 3 to kind of give you a heads up. We can see we want to write a new function. It has to be a vertical stretch of 3. So we just saw how to stretch something by 3, followed by a translation of 5 units left and 2 units down. So all that is taking this equation and plugging in the appropriate values. I want to stretch it by 3, fine, I make a 3. I want it to go left by 3. If I were to just put a 3 in here for h, that would actually give me a translation to the right of 3 because the h would be 3. Oops, I know I'm stuck on 3. We wanted 5 units left. If I were to put a 5 in there, that h would be 5. That would move it right by 5. But if I put a plus 5 in there, that will shift it left by 5. And 2 units down, so we just go minus 2. And there is our function. And we're done. It's moved left by 3, it's moved down by 2, and it's stretched by a factor of 3. So at 5, let the graph be a translation of 2 units that should be left and 3 units up, followed by a reflection in the x-axis, so we got to flip it over. So that means a negative a value. But it doesn't have to be stretched in this case. So again, we just start by writing down the vertex form. If I can get this to erase. And we go y equals a times x minus h quantity squared plus k. I got it to flip over. Fine, I put a negative 1 in there. You don't have to show the 1, you can just make it negative. I want it 2 units left. So that's going to be x plus 2, which forces the h to be a negative value. And 3 units up, so I'll make the k a plus 3, and that would be function g of x right there. Now, one of the things you can always do is pull up Desmos. You can graph it to see if when you get done, and I've got a few of these shown here, but if I was testing, I'd say, all right, I'd first graph my parent function. I've got it in green. Pull up the function we just wrote, x plus 2 plus 3. So I'm going to add a new function, y equals negative x plus 2 squared plus 3. And so is it shifted left by 2 and up by 3? Well, we can see it's vertex. That's left 2 and up 3. Is it inverted? Is it making the sad face? Yes, it is. And we know we're correct. Same exact size as the parent function, which is the other green function shown on this graph. So this is I should change colors if I can. That's our answer in red. This original green function is the parent function. All right. Problem number 6. Graph the function, label the vertex and axis of symmetry. All right, well, let's graph this guy. We don't have to be perfect. Again, we just want to be close. We want to be able to name that vertex axis of symmetry. Notice this is vertex form again. X minus h squared plus k. A is 3, right there. H is a positive 1, and k is a negative 4. So our vertex, right away, we can answer this. Label the vertex. We know the vertex is 1, negative 4. So let's graph him. 1, negative 4. There he is, vertex. What's the 3 tell us? The A value. It tells us it's going to open up, and it also tells us it's going to be narrow, stretched in the y direction. Before we do that, let's go ahead and draw on our axis of symmetry. I noticed on the quiz some people are still getting this axis of symmetry wrong. The axis of symmetry always goes to the vertex right down there, but the axis of symmetry is always just going to be x equals h. So in this case, x equals 1. And so there's our axis of symmetry. There's our vertex. Minimum value or maximum value. Since I know this parabola opens up, it goes up like this, it's going to be kind of narrow because it's a 3. I can see that it has a low value, a minimum value. That minimum value excuse me. The minimum value is the y value. So minimum of -4. What's the lowest value the parabola ever goes to? Describe where the function is increasing or decreasing. Always read this from left to right. In other words, as you follow this function going from the left-hand side, and you pick up the function. So here we go. What's the function doing? What's the y value doing? It's getting lower and lower and lower and lower until it hits that minimum value of -4. Then the function starts higher and higher and higher and higher. So we say it is decreasing when x is less than or equal, well, just less than 1 because it reaches its min. So it's decreasing all the way until x equals 1 where it hits its min, and then it is increasing, getting bigger and bigger and bigger, going higher and higher and higher when x is greater than 1. So the squared in and those two circled answers and our graph, because we had to graph it, are the solutions. Next page, we got about 4 of them left. All right, now this is where it gets a little bit tricky. Now we have to step out of vertex form and have to identify, oh, what form is this? And this form is what's called standard form. In standard form, you want to know this little expression or this little equation, -b over 2a. This tells us the axis of symmetry. And that's very important because our vertex goes through the axis of symmetry. So let's identify A, B, and C. Let's highlight them here. A has to be -2. B is in front of the x, so it's 16, and C is this thing dangling off the end, the constant part. So let's write those down. A is -2, B is 16, and C is 3. So let's find that axis of symmetry. X equals -b, well, -16, over 2 times A. Ooh, 2 times -2. Now, some people stopped there. You can't stop there. Just continue to work out the math. Negative over negative is positive, so x equals 4. So right away, if I'm thinking about the graph of this, x is 4 is my axis of symmetry. And that means my vertex is somewhere on this axis of symmetry. Well, how do I find it? Well, I know my vertex is at 4 because it has to have an x value of 4, but I got to figure out the y value. Well, how do I find it? I just go back here to the equation. The equation says the relationship between y's and x's. If I plug in any number for x, it will tell me what the y value is. Well, I'm not picking any number for x. I'm picking, hey, if x is 4 on this axis of symmetry, then what's the y value? That will pinpoint my vertex. I'm basically finding the g of 4. -2, so I replace my x's with a 4. And we do a little math. That's 16 when I square the 4. I got to square first. 64. It's -32 plus 64. I just add and subtract from left to right. -32 plus 64 is 32 plus 3. Holy cow. My vertex, the y component or coordinate, is 35. So this thing is way up here. And we'll just mark that as 35 and put a dot. There's my vertex. Now, we'll talk about whether it's a max or min in a second. Let's look at this a value. That's the same a we used before. The negative sign in the a tells me it opens downward. It's sad. The 2 tells me it's kind of narrow. So it just looks something like this. And that's a pretty good graph. Okay, let's label some things we know. Vertex, 4, 35. Axis of symmetry. We already found that at the very beginning. That's, oops, we should put, I need to be particular about this, x equals 4. Max or min, this has a maximum value, a highest point. How high does it go? It goes all the way to 35. So max of 35. Increasing, decreasing. Let's read from left to right. As I come in and start working the graph, see how it gets higher and higher and higher until I reach 35 for the maximum value. Right when x is equal to 4 here, then I start to come back down. So I'm increasing until x is 4, and then once x equals 4, I start to decrease. So increasing when x is less than 4, and then decreasing once x gets to be bigger than 4. So once I hit 4, right up here, I start to come down. Let's free up a little space here. We've got a different form now. So we've looked at vertex form, how to deal with it. We've looked at standard form now and how to deal with it. Let's look at this third form that they give us. This third form is x-intercept form. And this is a beautiful form. Its general form is y equals a, x minus p, x minus q, and p and q are x-intercepts, which is fantastic because if I start to compare these, I can tell right away p is 3. In this case, it's a little trickier. Q is going to have to be a -7. Negative of -7 is a +7. So those are my x-intercepts. Let's write those down. X-intercepts. 3, 0, and -7, 0. Ordered pairs. Okay. The y has to be 0 so that we're on the x-axis. So if you're trying to graph this thing, you can do it real quick. 1, 2, 3, 3, 0. X-intercept, -7, 0, 2, 3, 4, 5, 6, 7, -7, 0. So we know this parabola has to go through those 2 points. Next, we can find out where the axis of symmetry is. To find the axis of symmetry, all we're looking for is the midpoint of these 2 intercepts, because of symmetry, it has to lie in the middle of those. So let's just average those out. -7 plus 3 divided by 2. -4 over 2 looks like -2. So right there, all we did is add those 2 intercepts together and found that center line. You could do this by counting. Look at the count method. I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're 10 apart, so the midpoint is 5 from 1 3, 4, and 5. Right there. And that tells me the midpoint, which also tells me the axis of symmetry. X is equal to -2. I've just answered one of the questions. And just like in the previous problem, I now know where my vertex lies. My vertex has got to lie somewhere on this axis of symmetry. I know the x value for the axis of symmetry, therefore I know the x value of the vertex. It's -2 something. How do I find out that something? Well, I ask the equation or the function. I say x when you are -2, what is the value of the function? So we just do a little substitution here. H of -2 would equal -2 minus 3, just substituting in -2 plus 7. Do a little math. -5 times +5 looks like -25. So way down here at -25, there's the vertex. So vertex, we got that question answered. -2, -25. Which way does it open? We look for the a value. The a value is a +1. Means it opens upward. It's going to go right through those 2 points. And we've got a decent graph of that parabola. This has a minimum value, min of -25, the lowest value it goes to. It is decreasing when x is less than -2, and then it starts to increase once x is bigger than -2. I know I'm kind of going fast, but it's a video, so you can stop and pause it. Here's our last 2 types of problems. Write the equation for the parabola, given some information. In this case, they gave us a random point that it goes through, but they told us the vertex. Man, if you tell me the vertex of a parabola, I automatically go to vertex form. Remember, the vertex is h and k. So y equals a x minus the h value, which we know is 10 because they told us, plus k. Oops, they told us -4, so I'm going to erase that plus sign. Just put plus -4, which is -4. Like that. And I'm almost done. The only thing I don't know is a. This is where that other point comes in. This other point tells us when x is 1, y is 12. Fine. I'll let y equal 12. I'll let x equal 1. And I'll solve that thing for a. A little math here, -9. 12 equals 9 squared, 81. It'll be positive because we got double negatives. Now in this case, we got to take the 4 over first, undo that subtraction. 12 plus 4 is 16 equals 81a. And so a is divide by 81, both sides. Let's see here now, what are they both divisible by? 81 divisible by 16 is only divisible by 2 and 4, 8 and 16. I think that's as simple as we can get it. Now your answer, I saw this on the quiz, is not a. Your answer is the full function. This function, let's just call it f of x, we could put a y there, a g of x, whatever you'd like to, is the a value, and then your x minus your 10 squared, because we know the h, and minus 4. And that's the answer that we should end up with. Then our last problem here, find the equation of the line. It passes through this point. Here's its x-intercepts. They tell me x-intercepts. I'm going to use this x minus p and x minus q. I'm going to show you all these steps here. I'm just going to pull those x-intercepts though. X minus, here's the first x-intercept, -1 times x minus the other x-intercept, 5, like so. Let's clean this up. That double negative just becomes x plus 1. And again, my equation is done except for I do not know the a value. So let's go find him. How do I find him? I use that other point. They tell me when x is 4, y is 3. So if y is 3, x must be a 4. So every time I see an x, I put in a 4. We do a little math to figure out what a is. That's a 5. 4 minus 5 is negative 1. 3 equals 5 times negative 1 is negative 5 times a. Divide by negative 5, negative 3/5. Again, we aren't solving just to say a is this. We want to write our final equation. Let's use this one. A is negative 3/5, x plus 1, and x minus 5. And that is the equation for this parabola. That is it. Make sure you've tried the problems, then you look at the video, and then you come to class with questions.